Derive an expression for the induced EMF developed when a coil of n turns and area of cross-section A is rotated at a constant angular speed omega in a uniform magnetic field B. Okay. So here, constant, consider a coil PQRS of n turns, each of area A held in a uniform magnetic field B. Let the coil be rotated at a steady angular velocity omega about its own axis. Then let at instant t normal to the area, that is the area vector A, subtends an angle theta is equal to omega t from direction of magnetic field. Then at that moment the magnetic flux linked with the coil is given by phi b is equal to n times b vector times a vector, which is equal to n b a cos theta, which is equal to cos of omega times t. Therefore, induced EMF epsilon is equal to minus d phi b divided by dt with respect to t. We will get minus d by dt. Phi is nothing but cos of omega t. Then we get the resultant is minus NBA d by d theta times cos of omega t. Then we can write this one as, if you remove the negative symbol, then NBA minus cos of omega t is nothing but NBA a omega times sine of omega t. B case here, a wheel with 100 metallic spokes each 0.5 meter long is rotated with a speed of 120 revolutions per minute in a plane normal to the horizontal component of Earth's magnetic field if the resultant magnetic field at the phase is 4 into 10 power of minus 4 t at an angle of tip at the plane is 30 degree. Find the EMF induced between the axle and the rim of the wheel. So for this one, here the number of spokes n is equal to 100. Length of each spokes I is equal to 0.5 meter. Then the angular frequency, that is omega, is equal to 120 revolutions per minute is equal to, that is 120 divided by 60 RPS, revolution per second, which gives, that is 120 divided by 60 into 2 pi radians per radians here. Then which give the resultant as 4 pi radians. That means 61 times 62 times 2 into 2, 4 pi radians per radians. Then Earth's resultant magnetic field, that is BE is equal to 4 into 10 to the power of minus 4 t, and angle of dip is, that is delta, is equal to 30 degrees. As wheel is being rotated in a plane normal to the horizontal component BH of the Earth's magnetic field, hence induced EMF between the axle and the rim of the wheel due to any one spoke Derive the expression for the magnetic energy stored in an inductor when a current I develops in it. Hence, obtain the expression for the magnetic energy density. B part. A square loop of side 5 cm carrying a current of 0.2 amperes in the clockwise direction is placed at a distance of 10 cm from an infinitely long wire carrying a current of 1 ampere as shown. Calculate first one, the resultant magnetic force and the torque if any acting on the loop here. For this one, we will start with the magnitude of the induced EMF, that is epsilon is equal to L di divided by dt. Then if dq extra charge supply by the battery against induced EMF, then small work done by the battery is, that is dw is equal to epsilon times I dt, because epsilon is equal to L di by dt. Then we can write this one as dw is equal to Li times dt. Then we can write this one as W is equal to 1 by 2 Li square. Then for total work done, integrate equation 1 from limit 0 to I naught. Then we will get W is equal to integration with 0 to I naught Li at di. Then we can write this one as W is equal to L if we take the constant, then integration with the limits 0 to I naught I di, I with respect to I. Then we get W is equal to L I naught square divided by 2. Apply the limits 0 to I naught. Then we get the value W is equal to L I naught square divided by 2. Then UM we can write it as 1 by 2 times Li square. Then the magnetic energy produced in the inductor, which is given by B is equal to mu naught times Ni divided by L, and I is equal to BL divided by mu naught times N. Then the self-inductance of inductor is given by I is equal to mu naught N square times A divided by E. Then substitute the values of 2 and 3 in equation 1. Then we get the value UM is equal to 1 by 2 times mu naught into N square into A divided by L times B square times L square divided by mu naught square into N square. Then UM is equal to B square divided by 2 mu naught into A into L, which give the result UM by AL is equal to B square divided by 2 mu naught. Then the energy stored per unit volume called energy density, that is given by UM is equal to um divided by AL. This we can represent it by um bar. Then from equation 4, that is bar is equal to B square divided by 2 times mu naught.